Hi, this lesson is for section 6.1. We're going to look at constant percent change. After this lesson, 6.1, you should be able to try your quiz 5 that is open until this Sunday. Let's take a look. Yes, quiz 5 does cover everything in chapter 5 and just one 6.1 section. So please, after taking notes, try the homework on 6.1, and after you're done with 6.1 homework, you should be able to take at least the first attempt of your quiz 5. So let's go over I got about 3 big formulas. Well, let's say big, but simple interest formula, compounding interest formula, and the third one is going to be where we are compounding more than once a year, like compounding monthly, semi-annually, or quarterly. So those are the 3 formulas that we're going to look at. And the very last page, we're going to determine, is it a linear or exponential growth or decay? So about 4 examples to cover. Not that long. Section 6.1. Okay, so let's start with simple interest. We kind of worked with this before. Simple interest is interest paid only on the actual investment. So say that you're investing $5,000 for the next 20 years. You're only gaining interest on that original $5,000. So you're not going to get the most money in a simple interest case, but it is the simplest to calculate. All right, the amount of interest paid after 1 year is the rate multiplied by the original principal. Hold on. Okay. Example 1. So let's calculate the amount of money that we're gonna have at the end of this investment period by first finding the interest, and we're gonna add that interest to the original investment amount. Okay. All right. Assuming that you earn simple interest. So because we're gonna look at different types of interest today, look for these keywords. When you see simple interest, just know that in order to find that simple interest, 1 year amount of interest, I'm going to highlight this first sentence. The amount of interest paid after 1 year is the rate multiplied by the original principal. So let's take a look. You deposit $3,000 in an account with an annual interest rate of 4% for 20 years. So let's find the amount of interest first. The amount of interest after 1 year. That's simply going to be interest equals principal times the rate, right? Or APR, or the rate here. The original investment amount is how much? 3,000, right? We're multiplying this by the 4%. Or you can do 3,000 times 0.04. If you don't have a calculator that does, what's it called? Percent. But do 3,000 times 0.04. I'm doing it on my side, like a small calculator. 120. So what we got is that every year you will get an interest amount of $120. But how long is this investment period? Well, we're doing that for 20 years. So the total interest and over the next 20 years is going to be, well, there's $120 every year, right, for the next 20 years. So you will do 120 times 20, and that amount is 2,400. So this is how much you're making. This is your profit for depositing your $3,000 to this bank or somewhere for the next 20 years. You're letting them borrow your money. Now, what you want to calculate, though, is the amount of money you will have at the end of the investment period. So the total amount that you're going to have is, well, remember, you put this $3,000 in the account, so that money is still there. But you just we just calculated that that's the profit, that's the interest that we're gonna make. So to find your final answer, what you're gonna have to do is just simply add the 3,000 original investment amount plus that 2,400 interest that you got over the next 20 years. Therefore, your final answer is going to be $5,400. Okay? Now, I think I can give you a little formula here. The amount equals, the future amount equals principal times 1 plus the AP. You know what? I don't want to mess up because I don't think we really need a formula to figure this out, because we can just do step by step. But I think there is like a simple interest amount formula, but I don't have that with me here, so I'm just gonna do it just the way that we do it. All right, you invest this time $8,000. So later we'll add this amount, this original amount, to the interest that we're gonna make at an APR of 8.3% for 6 years. So what I'm gonna do first is I'm gonna find the amount. As you can tell, I'm being a little wordy today. The amount of interest after 1 year. And that's going to be the original amount times the investment amount times the APR, which is 8.3%. Now, if you are typing this into your calculator, you may want to convert this into a decimal. So do 8,000 times 0.083. 8,000 times 0.083. When I did that, I got $664. And this is per year, right? So what are we gonna do? Now, we're doing this for the next how many years? We're doing this for the next 6 years. So you know what I'm gonna do to this $664. I'll say the total, because I think some of you just read the notes that I write instead of watching the entire video, which I understand. So I just wanted to spell out everything, where these numbers are coming from. Total interest over the next, not 20 years, but what year is it? 6-year period is going to be, I'll do my 664 times 6. Now let's figure that out. 664 times 6 is $3,984. Now we are about to find the total amount. Now to find the total amount, remember we add the original investment amount plus the interest that we are going to get. So if you're gonna add your 8,000 plus 3,984, you'll know exactly how much money you're gonna have in 6 years. So this amount plus 8,000, $11,984. That's going to be the amount of money you'll have at the end of the 6-year time period. Now, this sounds pretty good, right? Well, that APR was pretty high, but let's talk about something even better, something called compounding interest. Because unlike simple interest, where you only get paid, the interest gets paid only on the actual investment, the original amount, compounding interest, they'll give you the interest based on what you have at the end of these compounding period. So, you know, the good news is you get more interest. You get more interest, but the formula that we're going to have to use is slightly more complicated. So I'm going to go ahead and give you that formula. But if you take a look right here, I got everything labeled. The amount of money is A. The money that you're going to have at the end is going to be A. The principal is P, the amount that you invest in the beginning. Y stands for the number of years, okay? Y stands for, oopsies, my pen's not working. Y stands for the number of years. And sometimes we just call R, but I can write APR. I'm just trying to use the formula that our textbook uses. So APY and APR, using these inputs or variables, here is the compounding interest formula, okay? The amount of money is going to be equal to principal times 1 plus APR, and you're raising that sum, you're raising that quantity to y power. Okay, so if I can add one more symbol here, let me do that. A equals P times 1 plus APR to the yth power. So we're going to use this. We're going to use this formula on example 2. Okay, now the keyword that you're looking for is compounding annually. If it says compounding monthly, we need to use something a little more complicated. But let's read example 2, and I'll tell you which keywords is telling us to use this specific formula. Calculate the amount of money you'll have at the end of the indicated time period, assuming that you earn interest compounded annually. Here we go. Whenever you see the keyword compounded annually, then you're going to use this formula, okay? All right, you deposit $3,000 in an account with an annual interest of 4% for 20 years. Okay, now this is compounded annually. So what's happening is, like the first year, you get the interest, 4% interest on that $3,000 that you originally put in. But then the very next year, what you're going to get charged, or not charged, what you're going to earn the interest on is not $3,000 anymore. It's going to be $3,000 plus 4% of that $3,000. So what that is going to be, I'm doing a quick multiplication here. The second year, you get interest on $3,030. So you will eventually get more interest. The interest that you get paid every year is going to be more and more and more, because in a compound interest, or if you're getting compound interest instead of simple interest, your original investment, I guess, or, well, the money always grows, but the money that you are getting interest on is actually getting bigger every year. Okay, so let's use this formula. But the keyword is compounded annually. Then we go with that formula. A equals principal. How much are we investing? 3,000, right? We're going to do A equals, the amount equals 3,000 times 1 plus, and if you think about 1, why is it 1? It's going to be 100%, but now let's talk about the APR. Now notice that APR is 4%. I'm going to go ahead and write this as 0.04. And we're going to raise this to the 20th power, okay? Now, we all have a scientific calculator, so we should be able to use that to type this entire thing in. And I'll do that. 3,004%, 20 years. Where is my calculator? I'll use this one. So type in 3,000 times 1 plus 0.04, close parenthesis, and raise that to the 20 year. Okay, if I hit enter, I get the answer is $6,573.37. So whenever you write,
your kids are anything like mine, then they're constantly wanting to be.
oh, I know what this is.
So as a mom, I have a lot more peace
Guys, because I downloaded a free app, every time I use something, they make me watch these ads. So maybe I should pay for it. All right. Let me go back and write down the answer, okay? So the answer amount, and I didn't really write down how I want you to round, because when we're calculating money, it's kind of, we always just round it to the nearest, what? Cents, right? So $6,573.37 will be the answer, okay? Now we can, and absolutely we can, find the amount of money if it was a simple interest, and it's going to be less than that. You want to try that real quick? Now let's focus on compounding interest. Let's do one more. Now this time you invest $8,000. All right, so your principal is 8,000. 8,000 times 1 plus, that part never changes, 1 plus, but then the APR, listen, the APR is, let me just use a different color, 8.3%, right? In decimal, that is 0.083. And you simply, what do? You divide by 100, okay? 0.083, and what's the exponent? What's the power? We're going to raise this to 6 power, okay? So that's what you do That's what you do. Let's go ahead and evaluate this. I'm going to my free calculator. Hold on. What I'm doing is I'm taking a picture of this equation on my cell phone so that when I go to my app, I remember what that equation was. So type in 8,000 times parenthesis 1 plus 0.083 close parenthesis. Raise that to the investment period of 6 years. I'm going to hit enter. Maybe I have to watch another ad. No, they didn't give me an ad. All right, so I'm going to take a picture of this answer. Wow. So our money grew from $8,000 to how much? $12,908.05. So that will be our answer. $12,908.055. So that's going to be the ending amount after 6 years. This is so happy, isn't it? Now I hope I did. Yes. Notice, guys, here's a good thing. We did the same exact problem on example 1B. We invested $8,000 at an APR of 8.3% for 6 years. We did that, but when we use simple interest rule, the amount that we got was less than $12,000, right? But if we did the exact same situation, $8,000 APR 8.3% for 6 years, but if the interest was compounded annually, notice it was over $12,000. It was close to $13,000, right? So the more frequent compounding, the more interest that you're going to gain and the more amount of money that you're going to walk away at the end of the investment period. So let's talk about the best case, compounding more frequently. And in 6.2, we'll talk about compounding continuously. But if this one was compounding annually, you can compound semi-annually or quarterly or monthly or even daily. So if you see those keywords, then you're going to have to go with the third formula, okay? So let's take a look at compounding interest formula, but a slightly different one, because where the previous one was always compounding annual, this one is going to be where interest is paid n times per year. N times per year. So semi-annual or monthly, those things, where everything else is the same, where A is the accumulated balance after Y years, P is the starting principal, N is the number of compounding period. This is new though. N is the compounding period per year. Period per year. So let me write down a couple N's over here. For monthly, your N is 12 because we have 12 months in a year. For quarterly, what do you think? N equals 4. For semi-annually, N is going to be, well, twice a year, 2. I think that's it. Oh, one more, sorry. For daily, how many days do we have in a year? Well, N's going to be very big, 365. So, I mean, in 6.2, I'm going to talk to you about compounding continuously. So, like, not even every second, not even compounding every second. So what are we going to use for N in those cases? Well, we'll talk about that in 6.2. But for these cases, if you can count how many compounding periods you have in a year, then here's the formula. A equals P times 1 plus APR divided by N raised to the N times Y power. So you'll use that formula if it says compounding monthly, quarterly, semi-annually, or daily. But for compounding annually, you just go with this one, the second one. All right, so let's go over about just 4 examples, and then I will be back to talk about how to distinguish linear or exponential equations. All right, let's try. You know what? Let me stop this one right here, and then I'll be back. I think my son just woke up. All right.